Logistic regression is like teaching a magical box to predict outcomes such as whether it will rain or not based on factors like temperature and humidity. Unlike simple yes or no predictions, logistic regression gives us probabilities indicating the likelihood of an event happening. It works by analyzing different factors and understanding their relationship with the outcome, helping us make more nuanced predictions. Think of it as having a weather wizard that can estimate the chances of rain using various clues, making it useful when situations are more complex than straightforward answers. Decision trees. Imagine you have to make a series of decisions like whether to play outside or stay indoors. Decision trees in AI work a lot like that. They are a way for computers to make decisions by following a tree-like structure. At the beginning of the tree, the trunk, there is a big question like, is it raining? Based on the answer, the tree branches out into more questions like, do you like playing in the rain? Each question leads to more questions until you reach an endpoint like, stay indoors and read a book. Decision trees. In AI, decision trees are used to solve problems step by step. For example, in healthcare, a decision tree could help doctors diagnose diseases. If a patient has symptoms like fever and cough, the tree might ask, is there difficulty breathing? Depending on the answer, it guides the doctor towards possible illness. Decision trees are like smart flowcharts, helping computers make choices just like you do, but by following logical path of questions and answers. They are powerful tools used in various fields to make decisions based on data and are easy to understand, even for high school students. Support vector machines. Support vector machines (SVM) in AI are like superheroes that help computers classify things. Imagine you have a bunch of different objects like apples and oranges, and you want the computer to figure out which is which. SVM is a smart algorithm that draws a line, or in more complex cases, a plane or a curved boundary between these objects in a way that maximizes the gap between them. Picture a game of catch where you have to separate two teams of players using a rope. The best way to position the rope is where it's equidistant from players on both sides. SVM works in a similar way. It finds the best liner or boundary that separates different types of data while keeping the widest possible space between them. AutoML system. These tools automate the process of choosing the right algorithm and preparing the data. Feature engineering. Creating new features or simplifying existing ones. Hypermeter tuning. Tweaking the models to make them work as best as they can. So viewers, today what we have learned so far, now we will see what is the conclusion. Machine learning algorithms are crucial, but they are not the whole story. Successful machine learning also involves picking the right features, cleaning up the data, and sometimes using automated tools to help out. Understanding all these parts is the key to making machine learning really work in the real world.